And it's not only that the phytoplankton is being infected, there's so many parts of the ocean that are being affected by climate change. And we're just trying to cover a couple of them today. But the next one we're going to look at is the reefs. So the coral reefs are also being destroyed due to pollutants as well as ocean temperatures. And pollutants, we keep saying that pollutants are a part of why these ecosystems are failing. And it's true. And there has been a lot in the media talking about how there's so much plastic in the water and how this isn't good for anybody, which is totally true. But the main cause for all the damage is due to the ocean temperatures increasing. So when the ocean temperatures increase, what happens is we say that the coral starts to go through a bleaching event. And what happens in this bleaching event is the temperatures increase and the coral goes into like a hibernation like state. It can't deal with the high temperatures, so it releases all its algae, and this turns the coral white because it releases all the algae, which has the color. So we say this is the bleaching state. So the coral is still alive in this state, but it's in a stress state and it's definitely not healthy. So it can survive in a bleach state for a short amount of time, but if it's in the bleach state for a long period or isn't able to recover properly, the coral is going to die off. And so not only is the high temperatures causing the coral to be in a bleach state, we got pollutants in the water, as well as I'll talk about in a second, the acidity of the ocean is increasing. So the coral has three things working against it to stop it from thriving. So the coral went through a huge stress state in a 3-year bleaching event that lasted from 2015 to 2017. And this is due to the El Nino. Now, the El Nino is a weather event that causes unusually high temperatures to sweep across certain regions. And this really hurt the coral reefs a lot to put them in a very high stress state where a lot of the coral reefs on Earth were getting bleached because of the high ocean temperatures and they're releasing their algae. So if we look at the graph below, this is satellite data showing how the reefs are doing based on ocean temperatures. So the level 2 alert means that the coral reefs are going through a bleaching event. Level 1 means they're starting to, and warning and watch means we've got to keep an eye on it. It's potential that if things change, that it could go into a bleaching event. And no stress means that the coral is functioning healthy. And we can see during this 3-year period or 3.5-year period, none of the coral was doing well at all over all of Earth. It wasn't just like regions on Earth. It was the whole Earth. The coral was not doing well. And this isn't the first time that during Earth's history that we've gone through a large or a long period bleaching event. It's happened up to 3 times before, or we believe 3 times before, it could be more. And each of the previous times, the reefs have recovered well, but what's happening now with climate change is not only is the temperature increasing because of this 3-year period where we had unusually high temperatures in the water, but the temperatures aren't able to drop as much because we're warming up the whole Earth. So they come out of this very stressed state due to the El Nino, and they're put under even more stress. They're not able to recover properly. So if we look at the next graph, this is what's happening, what we predict from May to August, based on kind of the last couple of months. This is new data of this year. We can see that we're worried about a lot of the world's coral still, that most of it we're watching, or there's a warning for. A large chunk of it has an alert 1, which means it's starting to go into a bleaching event, and some of it is currently in a bleaching event still, after going through this 3-year period of high stress. So we're not giving the coral time to recover from these unusually high temperatures, because everything's going to be high temperature now. It's not going to be unusual anymore. So not only is it the high temperatures and the pollutants, but it's also the ocean acidity is increasing, which means it's becoming more acidic, and that acid in the water is going to break down the coral. So the coral is not only dying, but it's becoming weaker, so it's easier to break off. So the coral is just getting hit on all sides so that it doesn't have a chance to recover. So I'll get more into the ocean acidity in a second here. But I just want to touch on the importance of these coral reefs. So these coral reefs have shown to hold the most diverse marine ecosystems on the planet, which means they have species and animals that cover a wide range of species. And they're able to thrive in one place because there's so much abundance of food and shelter from predators, as well as, yeah, I guess food and shelter from predators is kind of all you want as an animal. Um, so as the coral reefs die off, these ecosystems collapse. And the ecosystems that depend on this one. So let's say for all the sharks eating the fish around the coral reefs, when there's no more coral reefs, there's no more fish, there's no more food for the sharks. So it's not just one part of the ecosystem falls apart. It's that the whole ecosystem depends on each other. So when one part's gone, there's going to be consequences in other parts as well. And with all the other stress going on in the ocean, the last thing we need is multiple ecosystems failing. Okay, so back to the ocean acidity. So oceans do a great job of absorbing CO2, and without them, our climate would be warming up a lot faster. So the ocean absorbs maybe about a third of the CO2 that humans put into the atmosphere each day. So this has drastically slowed climate change, but it has led to the ocean becoming more acidic. So when the ocean absorbs CO2, it creates something called a carbonic acid. So this is an acid that's based on the carbon atom. Um, so over the last 10 years, the ocean has increased its acidity by about 25%. And that's not that, like the acidity of the ocean is not very strong compared to the acid in your stomach. It's very low. You can go walk in the ocean, you can swim in the ocean, you could spend years in the ocean. Well, it wouldn't be great, but, and the acidity, you might have other problems, but the acidity of the ocean won't affect you because it's relatively low level. But when you have organisms that are living their whole life in the ocean and that depend on shells, they're the ones that get affected the most by this acid, by the acidity of the ocean. So what happens is when you have shell life gets put in an acid, it crumbles. It doesn't. It's not as strong. So the shells that these animals have, just like with coral reefs, they get broken down and they're not as strong. So a predator can come by and just eat the shell, no problem, because they just crumble in their mouth under extreme circumstances. So as the ocean levels increase, shell life starts to fail as well. So because just because CO2 is being put in the atmosphere, and there's definitely other effects on climate change. CO2 is just what we're focusing on right now. Um, there's such a wide range of things that are affected by it. Um, so it's important to realize how everything gets connected in some way. That there's going to be some effects from like driving a car can lead to the shell organisms in the ocean not being able to live as well, or not being able to build shelter for themselves. So there's definitely other effects that the acidity of the ocean is having. This is just the one I chose to focus on today. And there's definitely more effects than what I've touched on here. We just don't have time to go into all of them because there's so many. So I encourage you to do some research or ask me if you want to learn more or have any questions. This is a really interesting topic because it's so relevant to now. It's so relevant to today, to your life, to your future. It's something that where if you like doing math, you're like, oh, this isn't, I'm never going to use this. This is something that is very relevant to your day-to-day life, is how ecosystems are potentially collapsing because our climate is warming up. Secret word today is ramen. So this is part one. Part two, I want to focus on how this change is affecting animals on land, or just kind of animals in general. Here is more kind of ocean life, so I guess it'd be more land life. And then part three, I want to look at how this is affecting humans. So how it is really affecting you day to day. And then from here, we're going to move on to the next part where I believe we're doing, actually, I don't know. Maybe I can find it. Let's see. So the next thing we're going to look at is after we look at the effects, we're going to look at what the future holds. So we're going to look at some scientists, how they're predicting what the future would be. So what are they doing to make these predictions? And then what the predictions say. And then from there, I'm going to introduce the final project for this class. So we're not going to have a final test, we'll just have a final project. And then we're going to move into how we plan to stop and slow down climate change. What are we not doing that we need to do? And what are we doing that's a good step? And then we'll finish climate change section, and then we're going to go into water cycle for a couple weeks, if that, and then we're done the course. So hang in there. I think everybody's doing a really great job of engaging the class. I've been really impressed with everybody. So thank you for that, and keep up the good work. Have a good rest of the day, and I'll see you next time.